In this video, I'm going to show you how to do AQA A-Level Maths Paper 2 from June 2018, question 17. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. A buggy is pulling a roller skater in a straight line along a horizontal road by means of a connecting rope as shown in the diagram. The combined mass of the buggy and driver, which is 410 kilograms. A driving force of 300 newtons and a total resistance force of 140 newtons act on the buggy. So there's 300 newtons here, and there's 140 pulling back. A roller skater of mass 72 kilograms is at the back, and a total resistance of R newtons acts on the roller skater, so there's an R here. Of course, there's a rope between the two, so within the rope there will be a tension pulling the roller skater forward and a tension pulling the buggy back, and they'll be equal and opposite. However, if we consider the whole system, we don't need to think about the tension. Okay, the first question is find R. So considering the whole system, we can use F equals MA. Now, what we can see is the forward forces, or the forward resultant, would be 300, and we'll subtract the backward forces, which will be minus 140 minus R. So that gives you the overall forward resultant force, and that's equal to the total mass of the whole system, which is 410 plus 72, times the acceleration, which we are told is 0.2. Okay, and all we have to do is solve that for R. So the left-hand side becomes 160 minus R. The right-hand side becomes, once you type that into calculator, 96.4. Rearranging 160 minus 96.4 is R, and we will then get the value of R. R is 63.6 newtons. And that completes part one of the question. Okay, next part of the question says find the tension in the rope. So at this point we need to either consider the roller skater or the buggy and driver. So from the point of view of the roller skater who weighs 72 has a tension pulling him forward, and the resistance R, which we had already established, was 63.6. So if we were to use the roller skater as the example, again we can do F equals MA, and we can see that T minus 63.6 is equal to 72 times the acceleration, which was 0.2. We can then see that T is equal to 63.6 plus 72 times 0.2, and then get T is 78 newtons. We could, of course, do the same thing with the buggy, and we'd have to include all the forces pulling the buggy forwards and backwards, and we'd have the same F equals MA, and we should get the same tension. Okay, the assumption that we've made is that the tension is equal on both the buggy and the driver, and that we can consider the rope as having no mass. So some obvious things would be the rope has no mass. We only need one, but other ones would be inextensible, so we don't stretch the rope, and another one would be that it's horizontal. If we were using the rope to try and lift the rider off the ground, as well as pulling him forwards, then the tensions would be altered by that, which we obviously are not considering anything like that. Okay, next part of the question. The roller skater releases the rope at point A when she reaches a speed of 6 meters per second. She continues to move forward, experiencing the same resistance force. The driver notices a change in the motion of the buggy and brings it to a rest at 20 meters from A. Determine whether the roller skater will stop before reaching the stationary buggy. So really the question here is how far does it take for the roller skater to come to a stop? In order to know that, we need to know the roller skater's acceleration. Now, at the point where the rope breaks, the only force acting on her will be the resistance force, which is 63.6. Now, if we're considering this as the positive direction, we really should think about this as being minus 63.6, and we can use F equals ma to work out her acceleration. So using F equals ma, we will have minus 63.6 is equal to her mass, 72, times the acceleration, and then solving for a, we will find that the acceleration is approximately minus 0.883 is her acceleration. Now she has a constant acceleration, so we can use the suvat equations. We know her initial speed, u, is 20. We know her final speed is 0, and we want to find s. So if we look through the suvat equations, the most convenient one is v squared is equal to u squared plus 2as. So here it will be 0, once we square 0, is equal to, her initial speed was 6, not 20. 6 squared plus 2 times minus 0.883 times s. And if we rearrange that, we will have minus 36 over 2 times minus 0.883 to get s. And put that into the calculator, and S is approximately 20.4 meters to 3 significant figures. Now, the buggy has stopped at 20 meters. She needs 20.4 meters to stop. So she's going to hit the buggy. So as 20.4 meters is greater than 20 meters, roller skater hits buggy. Okay, now there's a final part of the question here. Explain the change in motion that the driver noticed. So if you remember, the driver had a driving force pushing the buggy forward, and also had resistance opposing the forward motion, but also the tension was opposing the forward motion. Because if you remember, the initial force on the buggy was 300 forward, and then minus 140 and minus t in the opposite direction. So as soon as the rope breaks, tension is removed. So rope breaks, and then tension is no longer opposing forward acceleration. So that tells you you've got a greater forward resultant force, and therefore you have a greater forward acceleration. And that completes the question.